Hello everyone. In this video, we will see how selection sort repeatedly finds the smallest element from the unsorted part of the array and places it in its correct position. So this slide shows the algorithm and its explanation. So in the slide, the first line is nothing but the function declaration, which has four parts. The return type is void. This means it is not returning anything. Then the function name, that is selection sort. Then the parameter, so two parameters are there, array to be sorted and the total number of elements in the array to be sorted. And the fourth part is the body of the function. So over here we have declared the variable named minimum to store the index of the smallest element found in the unsorted portion of the array. Now then the next line is the for loop. So this outer for loop, it controls the total number of passes. It starts with the index 0 and it runs until n minus 2, because after placing the first n minus 1 elements correctly, the last element is automatically the sorted one. So after every iteration, the sorted part grows and the unsorted part becomes smaller. So to begin with, the sorted part is not containing any element and unsorted part is containing all the elements. So now the first element is considered as the minimum one. So at the beginning of every pass, we assume that the first element of the unsorted portion is the smallest one. So that is why the value of I is assigned to the minimum variable. Now, then the inner for loop, it searches the remaining unsorted elements, which is beginning with the I plus 1, because the current element has already been assumed as the minimum one. The loop compares every remaining element with the current element with the help of the line if a of j less than a of minimum. So this condition basically checks the current element smaller than, is the current element smaller than the minimum element found so far. If the answer is yes, then we have found the new minimum, and then that index of that new minimum element, which is nothing but the j, that we have assigned to the minimum uh, variable. So whenever a smaller element is found, we will simply update the index. Now, let us see this particular thing with the example. So now our array, input array, is containing these 5 elements: 64, 25, 12, 22 and 11. So the first element is considered as the minimum one and its index is 0. So mean will contain the index 0. Now this is getting compared with the 25. Okay. So 25 is less than that of the 64. So now we will update the value of the mean index. It is nothing but 1. Whatever is the index of j, that we are assigning to the mean. So new updated value of the mean index is 1. Now next iteration, we will compare 12 with the 25. As 12 is less than that of the 25, the new index for the mean is nothing but 2. In next pass, we will compare 22 with the 12. So, as 22 is not less than that of the 12, there is no change or updation in the mean index. Okay, mean will be 12 only. Now, in the next iteration, we will compare 11 with the 12. As 11 is less than that of the 12, the mean index is updated. It becomes 4. Okay, and the new value of the mean will become 11. So now what we will do, once we found the mean from the unsorted array, that mean from the unsorted array we will swap with the current minimum. So A of mean is getting swapped with the current mean, that is A of I. So this is the output of the pass one. Now in the, if you observed in the pass one, we can able to sort or place only one element at its proper position, that is 11. Okay, now we have to run the second pass. So in the second pass, what will happen, the value in second pass, the value of I will become 1. Okay, as the value of I will become 1, the mean will be 25 and the index of the mean is 1. So 25 is getting compared with 12. 12 is less, so mean index is getting updated. Now then 12 and 22 is getting compared. 12 is less, there is no updation in the mean index. Then 12 is getting compared with the 64, as there is no 64 is greater than that of the 12, so there will not be any updation in the mean index. So mean index will remain 2 only. So what it implies, we found the minimum element in the unsorted array at the index 2. So that we have to swap with the element with the current minimum element. So current minimum element is 25. So 25 is getting swapped with the 12, and now we will get the output of the pass 2 as this. So over here in the sorted array there are 2 elements, and in unsorted array there are 3 elements, that is 25, 22 and 64. This will act as an input to the next pass. So in the next pass, again we will repeat the same process. Okay, so after repeating the same process, out of these 3 elements, the mean is 22 and its index is 3. So that third index we are swapping with the next with the current mean. So 22 and 25 are getting swapped, and this is the output of the pass 3. Now in the next pass, the current minimum will be 25, and that is the minimum from the unsorted one. So there will not be any updation in the input array. Okay, it will be as it is. So this is the output of the pass 3. Okay, now once we got the output of the pass 3, as we have set the value of the second last element in the sorted array, this means the last element is also the sorted one. So whatever is the output that we got over here is the sorted one. So this shows the summary of every pass. So pass 1, pass 2, pass 3, pass 4, value of I is varying from 0 to 3, and the content of the array are getting updated in every pass. Okay, so what we have seen from the working, the insertion sort, unlike the insertion sort, the selection sort performs the same number of comparisons in every case, no matter whether your input is sorted one or unsorted one, because its working is basically based on finding the minimum from the unsorted array. So in order to find the minimum from unsorted array, it needs to compare each and every element. So in every case, that is best case, average case as well as worst case, the time complexity of the selection sort is big O of n square, where n is nothing but the total number of elements in the array, and the space complexity is the constant one, that is big O of 1, as it requires only one extra variable, that is minimum. Now, the advantages of the selection sort is easy to understand and implement. It requires the constant amount of memory. It performs a minimum number of swaps as compared to that of the bubble sort, and it is suitable for the smaller data set. The disadvantage of the selection sort is it is insufficient for large data set. As the value of n increases, the number of comparisons also increases. So it always performs quadratic comparisons even if the array is already the sorted one or partially sorted. So it is generally not a stable because equal elements may change their relative order after swapping. In short, let us summarize the working of the selection sort. First, we assume the first element of the unsorted array as the minimum one, then compare it with all the remaining elements, find the actual minimum element, swap it with the first unsorted element, and repeat until the array is completely sorted. So, selection sort is a simple and efficient for all for small data sets, making it an excellent algorithm for the beginners to understand the fundamentals of the sorting. Thank you for watching. Hope you found this explanation helpful.